Audio Jungle.
Hello everyone, welcome to my new video. Today I will show you how to configure MPLS option B from zero. As you can see here, we have two internet service provider, ISP A and ISP B. In these two ISPs we are using here the Juniper routers. Also we have two enterprise, and each enterprise in different area. So for example, here we are in the area number A, and here we are in the area B. Okay, so in our objective here to make reachability between these two enterprise, for example, we have this enterprise AB is HQ, and we have another branch in the area B. Okay, so our objective to make reachability between this one and this one. Also the same with the enterprise CD. So concerning MPLS option B, why we are using here the option B, not option A. So what is first the option A? The option A, it means we reserve each customer link. For example, when we have here 200 customers, so here need to link 200 link between ISP A and ISP B. But in the option B, no needed, so we can use just only one. Okay, but here in the option B need to configure the MPLS between these two ISP, and also we keep the same route target. Okay, the same route target. Concerning in the option A, no need to keep the same route target, because here in the option A we use this router send the routing table, not LSP. Okay, so in the option B need to configure the MPLS, also need to configure the next hop self, and also need to keep the route target. So first of all need to configure the IP. So first of all need to configure IPs. So let's start. Need to access in this router, so set interface giga 0.0.0.0.0.0.3. okay, unit 0, family inet address 10.0.0.1/30. okay, also need to configure the loopback. I'm using here 111. okay, or before configure the loopback, need to configure 11.0.0.1/30, but in the interface giga 0.0.2. also here the loopback I will use 111. okay, and here need to change the name. okay, loopback 0. okay, after that in the same time need to configure the IPs, and also need to configure the OSPF in the same time. okay, so I will use set protocol or set before routing option router ID, use the loopback 111, and also need to set protocol OSPF area 0.0.0, interface giga 0.0.2, giga 0.0.3, and loopback 0. This is for how to configure the IPs. Need also to configure IPs giga 0.0.4 and giga 0.0.5. okay, and after that when we configure the VRF and etc., need to add this IP. So let's no problem to configure giga 0.0.4. okay, with unit 0, family inet address we are using here 23. okay, 1/30. also about the 5 22, and here is 5. okay, then comment. This is for the first router. At the same time I will enable the MPLS between this interface with giga 0.0.3 and giga 0.0.2. I mean I mean in the ISP, okay, in the interface, only the ISP, not interfaces between the customer edge, okay. So set interface giga 003 unit 0 family MPLS, okay. Also the same one with giga 002, and also need to set protocol MPLS interface giga 002 and giga 003, and also the LDP will enable protocol LDP, okay, also with giga 002. Okay, then commit. Let's move to second router. The same one, I will give the IP, also the loopback, enable OSPF, and enable the MPLS. So set giga or set interface giga 003 unit 0 family inet. So here inet I will use 10.0.0.2/30, and also we have 13.0.0.1 in the giga 002, and also need to configure the loopback. Loopback I will use here 2.2.2.2.2, okay, and here need to change this one, loopback 0, okay, and also need to set routing option. Option here is router ID. Router ID I will use 222, okay, and set protocol OSPF area 000, interface giga 002, giga 003, loopback 0. After that, need to enable the MPLS giga 002 unit 0 family MPLS, the same one with the 3. Also set protocol MPLS interface giga 002, giga 003, also enable the LDP, okay, and with giga 002 also, then commit. Let's move to third one. Okay, set interface giga 0.0.0.2 with unit 0 family inet address. Family inet address is 11.0.0.2/30, and also 30 here and 1, but 12 with giga 003, and also the loopback is 3333. Okay, 333. Then here need to configure the loopback address or change. Also set routing option with router ID 333. Okay, and also set protocol OSPF area 000 and interface giga 002, giga 003, loopback 0. Okay, set also the interface giga 002 unit 0 family MPLS, also giga 003, and set also protocol MPLS interface giga 002, giga 003, also enable the LDP, okay, LDP and 02, then commit. Also with the fourth one, okay, the fourth one, set interface giga 002 unit 0 family inet address, okay, 13.0.0.2/30, okay, and also 12.0.0.2 giga 003, okay, and set interface or also the loopback /32, but here is 444, okay, and change the name loopback to loopback 0, okay, to loopback what? To loopback 0, and set protocol, or before set protocol, routing option, router ID is 444, okay, and also need to configure the protocol OSPF, okay, area 00, okay, interface giga 002, giga 003, and loopback 0. Then what? Then commit. Before the commit, need to enable also the MPLS set interface giga 002 unit 0, okay, family inet address. So the family inet, family not inet, MPLS, okay, and also giga 003, and set protocol MPLS interface giga 002, giga 003. So okay, now and commit. So no need to configure now the MPLS between these two ISP after finished all the configuration. Okay, so let's configure this IP as 14001. Okay, set interface giga 004 unit 0 family inet address. So here is 14001/30. okay, then what? Then commit. Let's move to second ISP, the same one with the configure the IPs, okay, and also configure the OSPF and same time the MPLS also, okay. So set interface giga 00. Let's start with giga 004 unit 0 family inet address. So family inet address here is 14002/30, and the same one with the giga 002, but here the giga 002 16, okay, 30, the same one, 16 1, okay, giga 002, okay, also with 17 but with giga 003, and also the loopback here is 555, okay, with the interface loopback 0. So now need to configure also the OSPF set routing option router ID is 555, and set protocol OSPF area 000 0 with interface giga 002, giga 002, giga 003, and loopback 0. Also, we don't forget to configure the MPLS in the giga 002, okay, unit 0 family MPLS, okay, also with giga 003, okay. Also need to configure set protocol MPLS with interface giga 002 and giga 003, then commit. Let's move to sixth one, okay. Set interface giga 002 unit 0 family inet address is what? 16002, okay, /30, and also giga 003 with 19001 and interface giga 003, okay. Also need to configure the loopback here is 666, okay, and change the loopback L0, okay. Also need to configure set routing option router ID is 666, okay, and set protocol OSPF area 0, okay, interface giga 002, giga 003, and loopback 0, and loopback 0. Also set interface giga 002 unit 0 family MPLS, also with giga 003 MPLS, and set protocol MPLS interface giga 002, giga 003, and also the LDP, okay, and to LDP, then commit. I don't know if we configure the LDP or not. Here, run show configuration protocol MPLS LDP. We didn't configure it. I forget, no problem. Protocol LDP interface giga002 giga003, then commit. It's okay. After that, the 7th router interface giga003 with unit 0 family inet address. Here is 17.001/30 and also 18/1. Here we have mistake, 17.002, not delete, and set here, set. Okay, now it's right, like this. 118 with giga002, and the loopback is 777, and change the name loopback 0. Loopback what? 0. Set routing option, also router ID here is 777. Set protocol OSPF area 000, interface giga002, giga003, and loopback 0. Then we configure the MPLS interface giga002, unit 0 family MPLS, also with the 3. Then set protocol MPLS interface giga002, giga003, and also with LDP to LDP, like this, commit. And the last one, or the last router in the ISP, set interface giga003, unit 0 family inet address. Okay, family inet address here is 19.002/30. Okay, and also with giga002 with 18.002, and the loopback here is 888, and loopback what? Loopback 0. Loopback 0. Set also the routing option, router ID is 888, and set protocol OSPF area 000, interface giga002, giga003, and loopback 0. And also need to configure this interface giga004, unit 0. Okay, family inet address is 20.001/30, and also with the giga005 but 21.001. Don't forget to configure the MPLS interface giga002, unit 0 family MPLS, also giga003, and set protocol MPLS interface giga003, giga002. Also need to configure the LDP, protocol LDP, and here commit. After we finish, now need to see the loopbacks in the same ISP, in the ISP-B, and also need to go in this router to see also the loopbacks. Let's check the routing table. Show routes, run show route. As you can see here, I didn't receive yet the OSPF, so now I received the OSPF. Now I can see 555, okay, in this router, okay, 555 and 66677 by OSPF. Okay, let's move to this ISP to check also the routing table by using run show route. Run show route. It's okay. Now the OSPF, I can see the OSPF. This is for the first step how to configure the ISP and also the OSPF. So now what we need to do, so we need to configure the the IBGP, okay, the IBGP between these two routers, and also enable what? Enable the VPN-v4 or Multi Bgp protocol, and also need to configure each community for each enterprise, and also need to create the policy to apply the import and export, and after that need to add these interfaces under the VRF, and also need to configure the static route between these two customers. Okay, this customer need to configure default route, okay, and here need to configure the static route. Okay, after that need to configure the external BGP and also enable the MPLS between these two interfaces. Okay, so let's start with BGP. Need to configure the BGP, internal BGP, then external BGP, then internal BGP here. So let's start. First of all, need to access in first router, okay, set protocol BGP. Okay, before configure the BGP, need to mention the our autonomous system. So our autonomous system here, I will use the 100, and in the first one, sorry, and second one we use the 200. So set routing option autonomous system 100. Okay, then set protocol BGP. So here I will give the group, so I will use IBGP. Okay, IBGP. Type, what is it? Type is internal here. Okay, type internal. Then I will mention the local address. Our local address, I will use the loopback. So loopback is 1111. Okay, and our neighbor, so I will make reachability between this neighbor. This 444. Okay, the neighbor 444. Peer autonomous system is 100. Okay, then what? Then commit. The same one with the second, or with second router here. Set routing option autonomous system is 100 also. Set protocol BGP, group IBGP. Okay, IBGP, type what? Internal. Also the local address here, what is it? The local address is here is 444. Okay, then our neighbor is 1111. Okay, neighbor in autonomous system 100. Then commit. Let's check now if BGP is up or not by using run BGP summary, run show BGP summary. So still in active state, need to wait. Okay, in the connect now is up. Okay, as you can see, our internal BGP is up. Let's now to configure the external BGP between this interface and this interface. So the update now I will use the, under the loopback, or send the update by loopback. So when you use the loopback here to make the neighborship, okay, to make the neighborship, need to configure also the static route between this in this router to reach this loopback 55, and here in this router to reach the loopback 44. Okay, so let's move now. Set protocol BGP group, but here the group not IBGP is BEBGP. Okay, the external BGP. Type not internal is external. Okay, and after that set protocol BGP group EBGP. Okay, local address need to mention also is 444. Okay, 444, and the neighbor is 555, but in the peer autonomous system is 200. Also need to configure the TTL. The TTL, as you know, in the TTL or multi-hop, in the external by default in the external BGP is 1, but here I'm using the loopback, so I will increase it to the TTL 2 or the multi-hop 2. So let's do multi-hop TTL is 2. Okay, then what? Then commit. After that, when we configure the BGP, need to configure also the static routing. Okay, the static routing, so I will do static routing option. Okay, static routing option, static route. Okay, static route to reach 555/32. Next hop is 14.0.0.2. Okay, then commit. The same one with this router, but here is second ISP. Set routing option. Here is autonomous system is 200. Okay, and set protocol BGP. Okay, set protocol BGP. Let's to configure first external here. Group eBGP. Okay, type external. Okay, then local address. The local address, what is it? The local address here is 555 and the neighbor is 444 with autonomous system 100. And also need to configure the multi-hop. Okay, the multi-hop TTL is 2. Then configure the static route. Static route is 444/32. The next hop, what is it? Is 14.0.0.1. Okay, then commit. Let's now check if external BGP is up or not. Okay, by using the same command run show BGP summary. As you can see, still inactive. Active. Why still inactive? Normally it will be up. Is up now. So now is up. Our external BGP is up. Let's now to configure the internal BGP from this router to this router. Okay, this is for what we did do now. We do just the external. Need now to configure the internal. Set protocol, or let's do it like this. Okay, set protocol BGP group iBGP, but the type is internal here. The local address also, the local address is 5555 and the neighbor is 888. The neighbor is 888 in the, sorry, not 66, 888. Peer autonomous system is 200, and here we have the next hop, so no need here, is okay, it's okay now. The next hop I will use it later on. Okay, so peer as, then commit, it's okay now, that's all. Okay, then commit. Okay, let's move to router 8 to configure the same. Set protocol BGP group iBGP, type internal, then local address, what is it? Is 888 and the neighbor is 555. Next, or the autonomous system is 200. Okay, then commit. Let's now also to check our neighbor. What is it here? We have the error here. What is it? The error is neighbor 555. Okay, we have the set protocol iBGP, local address is 888. Okay, and the neighbor is 555. Autonomous systems in error 55 of the group IBGP must define the local. Okay, we didn't configure the protocol. Okay, we didn't mention our autonomous system. This is big mistake. Autonomous system is 200 here. After commit now, there is no error. Okay, it's okay now. Let's now check our BGP is up or not. Show root or show BGP summary. Still inactive, active, still inactive. It now is up. Okay, if you're checking now the provider age here, you will see two BGP, one from the internal and one from external. Run BGP or run show BGP summary. As you can see here, we have two. We have one in the autonomous system 100 and one in the 200, and the both of them is up. So this is how to configure the BGP between this one. Now what we need to configure the VPN or the multi BGP. Okay, the multi BGP, and also to create the community to send each route for each customer. Okay, then need to import and export our route. Okay, and also need to configure the MPLS between these two routers. So first of all, what we will do in our lab, so we will finish in this ISP, then move in this ISP. So we will finish all things here to create community, and also send the import, export, and also configure the next hop self here, because in the option B need the next hop self for this neighbor and next hop self for this neighbor. Okay, so this is also need to configure it. Okay, so let's start with the first router to configure what? To configure the multi BGP protocol. So let's start. So first of all, need to set protocol BGP. Okay, which group IBGP, the group IBGP. Okay, the IBGP here, the IBGP here to configure family. Okay, family inet unicast. Okay, then also configure the VPN unicast. Okay, and also enable the root target. This is for the first one. After that, this is how to configure the multi BGP protocol. Now need to configure the VRF instance. Okay, the instance. So I need to set routing instance. So this is the routing instance. It means each VRF. So the first VRF is AB. Okay, the first is AB. Okay, set routing instance AB. Instance type is VRF. It means the layer 3 VPN. Okay, then need to configure route distinguisher. Route distinguisher, I will put it as 111.2.100. Okay, after that also need to configure or enable the VRF table label. Okay, so the same one with what? With the CD or the second VRF. Okay, and also need to change the router ID or route distinguisher, sorry, to 111.200, and here CD, and also enable the label table for the CD. After we finished here, need to configure the community, set policy option community. This is community for the first VRF, so I will give the name VRF underscore AB. Okay, AB. Then member, I will give this name target. Okay, target 110. This is for the AB. So this one must keep it in this router and this router and this router. Okay, this is must. Okay, after that need to configure also the community for the CD, but the member target 120. So I will give this name. Okay, After we configure the community, need now to configure the import and export. So what we need here to import and export, so in this router need to export the direct, this one, the direct, this link, the direct, and also this 999, because we will use the static route. Okay, so I will export the static and direct, and import what? And import the BGP. Okay, the same one with AB and the same one with the CD. So let's start. So how can configure this policy? I will set policy statement. Okay, policy statement. I will give the name AB. Okay, AB export. Okay, term. Which term? Term is let's start with the static. From protocol static. Okay, then what? Then send community. Then community set. Okay, VRF AB. Okay, then what? Then accept. This is for what? For the export the static. Let's do export also the direct. So I will change the term direct from protocol direct. Then what? Then send community. Then community set VRF AB. Then what? Then accept. Then accept. Now need to configure also the export for AB. Okay, so I need to not export, the import. Okay, the import. So I will import the term BGP from protocol BGP, and from what? From community VRF AB. Then what? Then accept. Then accept. This is for what? The policy for the enterprise AB. Let's now to move an enterprise CD. So set policy statement VRF or CD export. Okay, term static, the same one, with from static or from protocol static. Okay, from protocol static. Then send community. Then community set here is VRF CD underscore CD. Then what? Then accept. The same one with direct, and here direct, and then community set VRF CD. Then accept. And now need to configure the import. For CD, import term BGP from protocol what? From protocol BGP. Then what? Then or from community VRF CD. Then accept. Then what? Then accept. I will do not commit, not yet. Okay, after that need to apply this policy under VRF. Okay, set routing or set routing instance. As you can see in the instance, we have two instances. We have AB and CD. Let's start with AB and apply the VRF import to the policy AB import. Okay, and export for the AB export, and also enable for the CD and VRF export for CD what? Export, and VRF import for the CD import, like this. Okay, now we can commit if there is any error. I think there is any error, so it's okay now. Now what we can do we can add this VRF to under this interface Giga004, and plus we need to configure the static route under the VRF AB and CD, the same one. Okay, let's add this interface set routing instance AB interface giga 0000 for this one for AB, okay, and for the CD is giga 005, okay. And after that need to configure also the static route under the BRF routing option, static route to 999/32. Next hop what is it? Is 23001, okay. Then set routing instance for CD and routing option static route to what? To 10/32. Next hop what is it? The next hop is 22002. Sorry, here we have mistake. 23 is not 23001 is not next hop. The next hop is 23002, okay. Let's to correct it, can do like this, delete, and here is 2, okay, 99, okay. So like this is true, okay. Let's now what we can do now, let's move to configure the same policy here in this VMX, okay, in this VMX. Okay, so let's start. And in this router need also to add new policy called the next hop self, okay, need to configure it also. Let's move now. Before create, need to mention the protocol BGP, group IBGP, okay, IBGP, family unicast. So I will configure family iNet unicast. This multi BGP protocol need to configure between this router and this router, and also between this router and this router. This is for the MPLS option B, okay. So we need to configure it in the same group, or in the both of group IBGP, internal BGP, and external BGP. So also need to configure the VPN unicast, and also the route distinguisher, the route target, and also need to configure the same one with the group eBGP, okay. Also the route target in the eBGP, and VPN also in the eBGP, okay. So now we configure the multi BGP protocol. Now need to create the policy community, or the community. Before create the community, need to configure the VRF, okay, the routing instance VRF or the AB, okay. The VRF or instance type is VRF, and also route distinguisher. Route distinguisher is 444/100, okay, 100. Here is VRF label table, okay, VRF table label, okay. The same one with the CD, need to configure also the VRF CD, and the route distinguisher need to change it to here to 200, okay. But here CD, and also the VRF label table label, sorry, CD, okay. After we configure this VRF instance, need to configure set what? Need to configure set policy community. Need to configure the community. The community here is VRF AB, okay. Member the same one, targets 110. This is must write in the all routers, okay. Target 110. And also for the CD, just we do 20 here, CD. Let's now to configure set policy, our policy statement, okay, policy statement. Let's start with AB export will export the term static from protocol static, then send community, then community set, what is it, VRF AB, okay, VRF AB, then accept. The same one with direct, term direct from protocol direct, protocol direct, okay, then what, then community set VRF AB, then accept. Now to configure also the import, but here term is BGP from protocol BGP, okay, then or from community VRF AB, okay, then accept. This is for the first VRF for AB. Need to configure now same one with CD, okay, same one with CD now, CD export term static from protocol static, okay, then community set is VRF CD, VRF underscore CD, okay, then accept. The same one with direct now, term direct from protocol direct, and then send community set VRF CD, okay, VRF CD, VRF CD, then accept, okay. Now need to configure the import. The import for CD is BGP, term BGP from protocol what, BGP, okay. After that, from community VRF CD, okay, then accept, then what, then accept. After that, need to apply this policy under VRFs, but before apply this VRF, or let's apply to the VRF, set routing instance AB, okay, the VRF import with AB import, okay, with AB import, and export for AB export, okay, and also CD with VRF import, CD import, and VRF export with the CD export, okay. And this is for how to apply this VRF or this import and export under VRF. Now need also to configure the next hop self, okay, the next hop self in both sides, in this side and this, in this neighbor and in this neighbor, okay. So I can do set policy option, policy statement, next hop, let's give name next hop, term 1, then next hop self, okay, then accept, then what, then accept. Now need to apply this one under the BGP, okay, set protocol BGP in the both group, the group IBGP. I will do export next hop, okay, and also apply this group under external BGP, okay, external BGP, export next hop, okay, then commit. This is for what, for the VMX v4, okay. That's all for this one. Let's do the same one or the same policy in this router and this router, okay, the same policy. What we do, the same the same one. Okay, let's access to the first one, the first router in the next ISP. Okay, in the second ISP, how we can do set protocol or set protocol BGP IBGP. Need to configure first need to configure the multi-protocol BGP. Okay, family iNet unicast and family VPN unicast and root target. Okay, the same one with eBGP, the external BGP. Okay, root target also, and also the VPN with eBGP. After that, need to configure our instance. Okay, set routing instance is AB, instance type VRF, root distinguisher. Root distinguisher, what is it? Is 555. Let's do 100. Okay. Also VRF table label. Okay. Also need to configure the VRF for the CD and also root distinguisher for CD. Let's change here to 100. CD and also VRF table label CD. Okay, after we configure the VRF, need now to configure the community. Set policy community. We have first one is AB member target 110. This is must. Okay, and also the CD, but here need to change to 20. Okay, after that need to create the policy statement for the VRF AB or for AB export term static, same one, static from protocol static. Okay, then send community set is VRF AB, then what, then accept. This is for static. Let's do for direct from protocol direct, and also need to then community set VRF, be careful here for mistake, VRF AB. Okay, then accept. Then what, we'll configure import. The import for what? For AB. Term here is BGP, and protocol, what is it? The BGP from what? Community VRF AB. VRF what? VRF AB. This is for the first one. Let's do the same with the CD. Okay, let's do the same one with the CD export. Here the term is static from protocol static. Okay, then community set for the VRF CD. Okay, then what? Then accept. This is for the static. Let's do for direct from protocol direct, then community set VRF CD, then accept. Then what? Then accept. Let's do now the CD, but for the import. Okay, for the import here term is BGP from protocol what? From protocol BGP. Then what? From community VRF CD. Okay, then accept. Then what? Accept. After finish, now need to apply this policy. Set policy or apply this policy under the VRF routing instance AB VRF import, okay, AB import, VRF export, AB export, CD VRF export, CD export, VRF import, CD import, VRF import, like this. We have the no, not VRF, CD, sorry, CD import. Okay, now after before commit, need to apply the next hop self. I will create policy for next hop self for this router and for this router. Okay, set policy statement next hop term 1, then next hop self, okay, then what, then accept. Let's apply this under protocol BGP in the both group IBGP export next hop self, next hop, okay, and also for BGP. Okay, now commit. So now the same one with what, with the last router. Okay, the last router need to configure the same policy and the same need to configure multi BGP protocol. Let's do set protocol BGP group. See here we have only one group IBGP. Okay, IBGP family iNet unicast. Okay, also VPN unicast, also the root target. Let's do now set policy or set routing instance. First one is AB with VRF instance, sorry, not VRF, with instance type is VRF. Okay, and also root distinguisher is 888.2:100, and also VRF table label. The same one with CD. Okay, same one with the CD. Root distinguisher here I will change it to 200 is CD. Okay, CD, and here for the CD. Okay, this is for CD. After that we can do set policy or create the community. First one is VRF AB, member target the same one 110. Okay, this is for AB, and 20 for what, for CD. Need now to configure the policy statement. AB export, okay, term static from protocol static, then send community set VRF AB, then accept. Same one with direct from protocol direct, then set or community set VRF AB, then accept. Okay, also need to configure the imports term BGP from protocol from protocol BGP. Okay, after that also need to send community VRF AB, then accept. This is for first one. Let's do the same one with the CD. Let's start with direct with the CD. Okay, no problem. Then community VRF CD. What? Set. Forget set. Okay. Okay. CD, I think here. Okay. Yes, CD. It's okay. After that, when set the community, then accept. And what? Then accept. After that, need to same one with static, because we start already with direct from protocol static, and then what? Then community set VRF CD. Okay, then accept. Let's do now the import. Import term, but here is BGP from protocol what? From protocol BGP. Then from community VRF CD, then accept. Now need to apply it. Set routing instance AB VRF import. So AB import, export for AB export, then go to the CD VRF export from CD export, then import from the CD what? Import, like this, and commit. Now we finished the root policy. It takes time, okay, so no issue, but this is how to configure. Need now to configure or add the interfaces, the interfaces to each VRF. Set routing instance AB. Okay, the interface Giga004. Okay, as you can see in our lab. Okay, and the CD for what? For Giga005. Okay, also need to configure the static route for AB routing option. Okay, static route between 11 to 11/32. Next hop, what is the next hop? Is 20.002. Okay, the same one with the CD routing option, static route. Okay, static route. What is the static route? Is 12/32. The next hop the next hop is 21.002. Okay, then what? Then commit. This is how to configure. Let's configure from Cisco side. Okay, from the customer edge. Enable conft interface Ethernet 10 IP address. What is the IP address here? Is 23.002.255.255.252. Now shut down. After that, need to configure the loopback 0 IP address. Here is 999.255.255.255.255. Then IP static route or default route 002.23.001. Okay, then WL. Okay, this is for first enterprise. Let's do with second one also. Enable conft interface Ethernet 0 IP address 20.002.255.255.252. Now shut down. Interface loopback 0 IP address is 10.10.10.10.255.255.255. Okay, IP route 0.0.0.0.0.0 to 22.0.0.1. Okay, and also in this router, let's access the static. Enable conft interface one's IP address 20.0.0.2.255.255.252. Now shut down. Interface loopback 0. IP address is 11.11.11.11 Then IP route 0.0.0.0.0.0 to 20.0.0.1. Okay. Let's now move to the last one. Enable conft interface 10 IP address 21.0.0.1.0.0.2.255.255.252. Now shut down. Interface loopback 0 IP address with 12.12.12.12.255.255.255. Then IP route 00. Okay, 0 to what to 21.0.0.1 W. Okay, let's now check our configuration. Let's check the static the routing table here. What we can see from this one, from this run show route. As you can see here, we have the routing table here. Let's move to the routing table of the. We have some routes on BGP from the VMX. I'll learn it from this one. 16. I can see the 16, 17, 19, 18. You see, by BGP. This is from the ISP. Okay. And let's do from this one. Let's check this routing table. Show IP route. Show IP route. Or show IP route in Cisco. Okay. Show route directly. Okay. As you can see here, we have the routing table AB. I can see what? I can see only the static 999 and 23, this one. Okay. And in CD, I can see 10, 10, 10 and 12. Why? We cannot see the external one like 11, 11, 12 because we didn't enable what? We didn't enable the MPLS between these two ISPs. So let's start to configure the MPLS. Set interface giga 004. Okay, unit 0 family MPLS. After that, need to configure also the LDP. Set protocol MPLS interface giga 004. Also need to configure under protocol LDP. Okay, then commits. This is for this VMX. Let's do the same with this router in the same interface giga 004. Set interface giga 004 unit 0 family MPLS. Then set protocol MPLS under interface giga 004 and LDP also. Then commit. Okay. If you're now checking again, now. I think we have okay. This is VMX1. Also the AB. Let's do run show now. 99 still CD. Let's refresh again. Can't see it yet. So after checking now, I'm checking now what's the error here. If you're now checking the MPLS is enabled here in the 2, 3, 4. As you can see here, if you check now the LDP, as you can see the LDP, we forget to add giga 003 and giga 002. Let's do also set interface or set protocol direct LDP interface giga 002 and giga 003. I think this is big mistake. Okay, if you now checking again here, if you can see or not, run show root, this is for AB. So as you can see here, look to the routing table. The routing table, I can see the 999, this one, and I can see 1111, this one, 1111, and I can see the 20, this one, 20, by what? By BGP, okay, and I can see 23. Okay, let's move to the CD. Look to the CD, the routing table of the CD. I can see 101010 by static. I can see 1212 by BGP, this one, okay, and I can see also the 2100 by BGP, and I can see the 22 as a direct connect. Now if you checking now the ping from this router, the enterprise AB, to this enterprise AB, okay, let's do the ping to what? To 11 source what? Source 999. As you can see, the ping is successful. Okay, also let's do the same one, ping from this one, ping to 12 source 10. As you can see, also the ping is successful. So this is how to configure the MPLS option B in Juniper routers. Thank you so much for your watching and consideration. Don't forget to subscribe my channel, and thank you for your watching and consideration. See you in the next video.